Hello and welcome to Deriving Me Crazy Math Help. My name is Tori and I will be your tutor today. And we're going to be covering topics in this channel from Algebra 1 to topics in Calculus BC or Calculus 2, which is what it's called in college. And today we're going to be working on some college level math in Calculus BC/Calculus 2, and the topic will be trigonometric substitution. In trigonometric substitution, we're given an integral in terms of x, and we're going to use trigonometry to help solve it. So that way we can get rid of these radicals in the denominator. For those of you who are exposed to a lot of integrals with arc sign, you'll faintly recognize this setup right here with the root 64 minus x squared. That's very similar to a lot of arc sign setups, but the only problem is that we have our x squared. So what we're going to need to do is use trigonometry to solve this problem. And in this case, it's going to be x equals a sine theta would be our rule for using for this problem, which will help us out. So let's get started, okay? And let's first find everything related to x. So that way, if we can identify what the terms are in trigonometry, then we can plug it back into the equation and solve using trigonometry. So now let's do x squared. So right here, what they've already given us, or what we've given ourselves here, is a sine theta. A is going to be a number that is, so if this is 64 here, represents a squared. So 64, the square root of it is 8. So that would make x squared 64, since it's a squared, sine squared theta. If you have any further questions or want any other ways to rewrite this, please contact me on my channel and I'll be able to help you out. Okay, now let's go to dx. I know it may seem like it just goes away at some points when solving the problems, but it's still there and it's very important. So what we're going to need to do for dx is we're going to rewrite it as 8 cosine theta. And that'll be d theta. Because basically what we did was we used 8 cosine theta and solved in terms of d theta, so it was dx over d theta. If you multiplied both sides by d theta, you get 8 cosine d theta. So that's how we got our answer there. And the next one is 64 minus x squared. So another term we have to rewrite. And this term is going to be rewritten as 8 cosine theta. So this is going to be very useful to find this right here, the root 64 minus x squared, because it's in this form where it's like a squared minus x squared, or u squared minus x squared, something along those lines. And this is like a square number right here. So that's how we got our 8. But we also plugged in our a sine theta for x squared and solved for cosine theta. So that's how you got the cosine theta part of this. I know this may seem very fast, but definitely contact me and I will provide more detailed notes if necessary. So let's put everything together now, so that way we can see it all better. So first, what I recommend doing is pulling that 2 out of there, to the other side of the integral. It just looks a lot cleaner and easier to work with, in my opinion. Just don't forget the 2's there, that's all. That's the only part when it comes to bite you in the butt if you're not careful. So first, you should write this as 8 cosine theta d theta. The reason I'm rewriting it this way is because dx is still here and it's going to be in the numerator where that 2 was. And then in the denominator, we're going to have 64 sine squared theta times 8 cosine theta. So now, something that we can easily identify is that the 8 cosine thetas are can be canceled out of this problem. So they're gone. So now what we're left with is, so 2 over 64, since if we pull that 64 out of there, that'll give us 1 over 32, 1 over sine squared theta. So now this should be very familiar to you if you know your trigonometry really well. Then it can be rewritten as 1 over 32 times cosecant squared theta. On my YouTube channels and Instagram and some of my other social media, I can also further explain and show some of these really important tips for remembering trigonometry and how to translate like 1 over sine squared x to cosecant squared x. So keep your eyes peeled for those hints and reminders. So now let's look at this not root, but the integral of cosecant squared theta. So now, if we look at that closely, then we'll know that we'll have to be brought back to the memory of what the derivative of cotangent is, because the derivative of cotangent theta is negative cosecant squared theta. That'll be very key, a key player or a tip to know for this integral right here. So if we plug it, so now we can easily identify, we know what this integral is, because just without the negative sign, we'll have a cotangent theta. So that now we know our chain rule adjustment here is -1, since it would have been, cosecant would be negative if it was the derivative of cotangent. So now let's do this. So now we're left with -1 over 32 cotangent theta. I don't know if you saw on the very front page on my channel the triangle I had. When you first saw this video, you may have seen this. This is very important when solving these problems. I feel like it's really helpful. So what you want to do on this side of the triangle, we're going to put our x, and on this side we're going to put our 8. And then here we're going to put the 64 minus x squared. So the square root of 64 minus x squared. So now cotangent we know is also written as cosine theta over sine theta. This is really helpful because if you remember your SOHCAHTOA, that still helps you out in geometry, and it also helps you in calculus. So that's why I find it really important to remember that. So remember, sine is opposite over hypotenuse, and cosecant is, or not cosecant, but cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So now if we do this, we can also rewrite cotangent so since it's cosecant times, or cosecant divided by sine, we know, cosine divided by sine. Cosine is a over h, and sine is opposite over hypotenuse, but since we're dividing, we do the reciprocal, since it would be like dividing fractions. And now watch the h's cancel out, and you're left with adjacent over opposite. So now our answer is going to be -1 over 32 times, now let's look at this. So adjacent to theta. So what's the angle what's the side adjacent to theta? Is root 64 minus x squared over what's the opposite of theta would be x. And this will be your answer. And you can check your answer by taking the derivative. I won't show that here, but it will help you to verify and make sure your answer is correct. Thank you for listening to the Deriving Me Crazy math help here today. And I hope that you understand trigonometric substitution a lot better this time. And if you're still struggling, definitely let me know, and I'll also provide you with some more resources. Thank you.